Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about dedicated freight corridor. So let's dive right into it. Well, first you have to understand this is a big project and it is being basically taken care of by Dedicated Freight Corridor Corporation. It's a public partnership kind of system, and DFC Corporation of India Limited, basically the whole centerpiece. This thing that's supposed to take care of everything was established in 2006. So this is a project that is long in making, so to say. And the idea of this puppy is basically make an independent railway network, but with sole job, like the sole reason why this dedicated network will be built is to carry freight. It's in the name, Dedicated Freight Corridor. Now, because of the scope of the project, it was decided to create it in multiple segments. Primary segment, aka Western Corridor, basically these are the segments that are built first, will take care of one section of India. Basically, India has four golden quadration. So one side will be taken care of, that Western Corridor. The second side will be taken care of by Eastern Corridor. These two will be built as a quote-unquote feasibility study. Like we did the maths, we built it. Now let's see whether there is a demand or not, whether it's profitable or not. So question becomes, why do something odd like this? Well, reality is rail freight traffic is dropping. Now, Indian Railway goes back to like very back, and in 1950 they had the simple reality. They were taking care of 85% of freight traffic. Basically, if India was moving 100 tons, 85 was directly moved utilizing a freight system. Now, over time, it started to go low and low and low and low and low, and there is a very serious trend. Like this is continuously going down and down, and basically road traffic started to overtake it in 1990s, and it's going further. So at this point in time, road traffic, like basically when they did the finalize the final study, that was at like 2015, they were like 58% is being moved by road. Now here's the deal, road system is not designed for this kind of bulk transportation. It's good for like last mile of travel, basically from railway station or from port to your home or to this last mile, basically not for bulk travel. Basically, if you are talking about connecting a one large factory with another large factory, utilizing links of trucks to do that, it's unwise solution, simply because it's not built for that. Roads are not built for that, and Indian roads are specifically not built for that. Like wherever many places they have highway going through, basically very dense population, they slow down, they jam up, and I'm talking like this is really bad for every single front, like not only for the roads, only also for the trucks and also for the railway, because railway makes most of its profit from freight system. So it's like everybody is losing because of the congestion on the primary railway network. Railway network is like too overstretched. It's like everything is overbooked. Everything is like overbooked, as in like each track has to sustain passenger traffic, express traffic, and freight traffic. It's a single track. How much can it do? So that's the, and now because of the increase in road traffic, the dependency on oil became much severe concern. It's like now whole India's infrastructure runs on oil. That is unwise system. Now Indian Railways slowly over time started to move away to basically from diesel locomotives to electric locomotives, and we have been very successful with that. So this becomes basically everything we saved in that area we are losing in this. So we have to remove this, and it will improve our freight infrastructure, because if done correctly, your freight traffic done through railway networks will cost you less and cost you less time also, and it will be also higher reliability, because you won't have randomly, hey, truck broke down or things of that nature. While it does happen in trains and all that jazz, it's like probability is very low. So that is why, like, it's not an optional thing. We had to do it. We had to do it to save everything else, basically. Now, what are the tools that are employed in this dedicated freight corridor that will allow for such kind of like basically taking back the chunk that road traffic has taken away from it? Step number one, double stacking. Basically, containers are becoming more and more primary means of transportation, and over time that will become the only mode of transportation. So, as in like bulk transportation, and we do have basically trains that are solely built to carry basically containers, but they are generally single stack. Basically they have one layer of system. Everything is awesome, but because we have electrical overhead wire, double stacking was not an option. However, dedicated freight corridor was built for freight, so from day one they were like, okay, we allow double stacking. This improves packing efficiency to a point where your same train can carry much higher loads. Now you may be like wondering, what about the railway tracks? Because railway tracks are rated in what we call axle load, how much weight each axle of a bogie can dump down on tracks. So generally Indian railway tracks are rated for 20 to 22 tons, good ones. This puppy is rated for 25 tons, so it can easily carry this system. Now when I'm saying 25, it does not mean if you put 30 it will crack. It's just like 25, it's expected, like everything is designed for that, and track is overbuilt for management concentration is to around 30. So because the track is strong enough, it can carry this dual stack system, and because this is a completely dedicated new build system, the overhead wiring would be specifically designed to allow this, and that will make it a world's first dual stack container carrying system with electrified network. Now, tonnage capacity, basically think of it this way. India has a lot of mines, and a lot of mines have coal mines, and those mines produce a lot of coal and ship it to different power companies. Now generally power companies book a whole train. They're not going to book like one carriage or something like that. They're going to like a whole train. Now one train is on a railway network is limited to 5,000 ton. Basically once they reach that maximum, it's like nope. Now that's good and all, but that's not enough for modern infrastructure. We consume a lot more tonnage at this point in time. So the new trains that are specifically targeted for DFC, they are gonna be allowed for customer wise to go up to 13,000 ton. That is more than twice in that. Now why is that significant? Think of it this way: instead of booking 2 or 3 trains, you have to only book one train, and you will get all of that delivery in one go. That means your buffer can be filled up to much larger extent, and you will have much better safety in terms of road I'm saying basically market fluctuations and all that. So people generally, in some scenarios, you really want to stack up your stuff. So in those sort of scenario, that extra tonnage, awesome. Now max speed, think of this way: let's say something happened, like world lockdown happened, and your basically locomotives are like, we got the horsepower, we got the load behind us is very light, we have the clear track, there is no interference. Can we go YOLO? Short answer, no. The railway tracks are limited to, for freight traffic, limited to 75 kmph. That's not that far, but for dedicated freight corridor, that is for 100 kmph. Now you may be like, that's a very little upgrade. That's not the selling point. That's not why we are focusing here. The focusing is like the primary reason why freight is so slow is simply because it has to give way for two systems: express system and passenger system. So if you take that away, so once you actually do the final calculation, it's like point A to point B, what was the average speed? The Indian Railways average freight speed is around 25 km per hour. That's why people started to move away from basically freight traffic to basically road traffic, simply because even a truck on a busy street can move much faster than this. So that is the main selling point. The main aim is to make sure this number is at 70 no matter what. Like it has to be above 70, below 100. That's the target point. So if that can be done, you are talking about taking point A to point B, which is connected by road around 3 days, can be done in 1 day, less than 24 hours. So that is a very critical aspect, that average speed. That's why it's supposed to take back the market share. Then the length of the train is also a critical aspect, because many times you may have something that is not double stackable, basically coal, grains, things of that nature, they are not double stackable. So in those sort of scenario, you have to increase the length, even though you have the tonnage capacity. But what if your train is not long enough? So they have solved that issue. So normal freight trains in India is around 700 meters, which is good, but this puppy will go around 1.5 kilometers. That's why you will see a lot of Indian videos talking about 1.5 kilometer. That's the sole reason we are achieving that kilometer mark, because the dedicated freight corridor is specifically built to accommodate those sort of ludicrously long trains. And to take care of what we call basically final delivery issue. Think of it this way: let's say you are two hubs that I'm talking about, like say one major port, another major. What if you are going from some major port to some major port? If there is no major infrastructure there, then you are in an awkward situation where you have to, let's say you are shipping a bulk load, and that bulk load is 100 ton, and 100 is too much, let's say 20 ton, and you're like, okay, I need to book a cart for that, let's say a railway cart for that. So you have to book a truck that ships it from your factory to railway cart, and then another truck from delivery point to, from that railway cart to truck to the final delivery spot. So what if you bypass the train and you just said, hey, just use the truck itself, truck on basically tracks itself? Now this has been done in many Western countries, and it's generally called roll on roll off system. Some place in India, they tried to do a trial run for this on a small scale, and it was very successful. And there's truck drivers, like there are actual truck drivers in these trucks, and their idea is like, we had to be driving for upwards of 2 or 3 days to take from point A to point B. When we are riding on top of basically railway system, all we are doing is basically sleeping at that point in time. They don't actually have to do the driving, and once it's done, they save a lot of fuel. And even if they directly compare, like how much fuel you would have spent if you have driven there, and time versus how much money you paid for railway to like take care of you, all those scenarios, it's always beneficial to utilize railway. And this also solves the problem of like, what if you are not in like major hub? What if you are in a middle place where it's like, dude, I need to book trucking because it's an important part. It's like, just book the truck the whole way around. It's like much more efficient, especially for small scale to small scale. It's not something that you're supposed to do if you're shipping hundreds of tons of coal. Again, in those sort of scenario, you're gonna utilize dedicated tracks for that. And if you're talking about like bulk shipments of thousands of tons, of course you're gonna use container ship. But somewhere in that middle road, this roll on and roll off transportation makes sense. And dedicated freight corridor from day one is been built with a way they're planning to incorporate this. I provided the video down below. So what kind of technology we're gonna employ to make this happen? Well, new locomotives. Indian locomotives are generally rated from around 3000 horsepower to 5000 horsepower each locomotive. But to pull this puppy off, we are targeting around 12,000 horsepower. So one of the new dedicated equipment built for that is WAP12. Now this puppy is a dual system. The reason why it's dual system, because they could have made it in one unit, but the axle load was exceeding the maximum specification. So they are like, yeah, let's spread it out. And spreading it out also improves what we call traction efficiency. So they are like, yeah, let's just spread it out. And there are other systems also where it's not like this is the only locomotive we can use. There are options of using two older generation locomotive, each are like 6000 horsepower, and lot of systems are being built right now to accommodate this. There will be whole plethora of railway locomotives while the track length is same. So yes, you can directly basically drive the same locomotive in normal railway network and in dedicated freight network, as long as you have the pylon for it, because again, overhead wire has been increased significantly. So this section is classified as high rise overhead electrification, OEH basically. So this high rise does require your locomotive to have a different kind of pylon, so to say. Now if your locomotive has this pylon, that's the only thing you have to change, and you can directly drive off either in dedicated system or normal system. And even over time, railway is trying to basically upgrade the wiring system for whole basically railway. The reason for that is like, if you can ship the double container directly to end stop, that will also save a lot of money. So they want to accommodate that. And the early testings are showing some hurdles, but they have been taken care of. Is like generally you're supposed to use the trailing edge one, and they tried to use that, but problem it was never doing, giving sufficient contact. At 80 kmph it was giving a lot of sparks, it was unstable. So they tried to use the front edge, and then they realized it was a wind effect, because at that high speed it's acting like a spoiler and it's trying to being pulled down, and because of the height, the spring is not powerful enough at that point in time. So they had to utilize the front one. Now again, redesigns have been made to make sure that it's not an issue. So these are two major innovation. First, make sure the cables are high enough where it's not gonna short out to the containers. Second, have the locomotives that are powerful enough to pull that heavy weights and all that jazz. And tracks are welded. Now many Indian railway tracks are already welded, but those are like add-on. Basically they were non-welded, now they are welding it. Some segments are welded, some segments are not welded. So it's always based on your luck where you're gonna end up with. But for dedicated freight corridor, because it's built with new everything new in mind, everything is basically dedicatedly built with welded rails. Benefit, it has ludicrously strong links, and if you see any railway video, there is a dynamic sound difference where your sound will go khatak 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 to whoosh. Like, it's mind-boggling how different the sound is there, simply because the whole system is basically welded rail from point A to point B, not like oh, in small segment here, small segment here. No, it's like point A to point B, and only places it has a jointed segment is where it's crossing over bridges. Now, every aspect of this, because this is a very large investment from Indians, basically taxpayers, most of the things are made in India. We are not trying to, like, quote unquote, buy products from somewhere else. We are buying designs. Basically, in case of this locomotive, designs are bought here, and then subsequent pieces. Basically, first piece will be brought here, then they will do testing, then we're gonna keep manufacturing it in India. Almost everything is being built in India. It's like basically providing a lot of money to Indian manufacturing industry itself. Now, what is the hope of doing this? Because if you are fundamentally try to understand the money we are spending here, it is one of the most expensive public infrastructure project. It's like, it's ludicrously expensive. So why the heck we are doing it? Well, it will help us in two core fronts. Number front was, it will reduce congestion on our roads and railway, because railway, rather than taking care of three demanding puppies, they only have to take care of two demanding puppies, like express railways and passenger trains. And they, of course, they will have some still last mile travel systems where, like, dedicated freight corridors are targeted for Delhi, Mumbai, Chennai, Kolkata, and direct link. But what if you are in between somewhere? Of course, you can still utilize freight from normal trains, but those will be like, very low volume. Basically, volume will go down from 10 freight trains to 1 or 2 freight trains. So it will reduce congestion on railway system and road also, because again, road will be freer, and highway is like kind of luxurious kind of infrastructure, should not be used as a like backbone. So it won't be like that. Also will become much more efficient. then speed up of everything also, because passenger trains, they don't have to like keep trying to accommodate three puppies. And freight, because the system is dedicatedly built for that, it will go full speed at 100 kmph, and they are trying to achieve 80 kmph average speed. Like they are making sure that average never drops below 70, and 80 is their goal. And it's a long-term stable backbone. Like when I made a last video about bullet trains, I specifically talked about China trying to do this, and China did successfully do that. However, it's ludicrously expensive. They're never gonna make their money back. However, that investment is directly into the infrastructure of their country. Over time, it will yield dividends, as they say. And so India is doing something similar. Think of it this way. Let's say you have built something in Delhi, something big, something awesome. You want to ship it to everywhere. Right now, you don't actually have any reliable, cheap, efficient method of shipping it to multiple ports. Now let's say you found out, hey, Calcutta port, which is the nearest to you, is like, hey, those are overbooked, you're not gonna get good deal on that. You may find, hey, China, I'm saying Chennai, basically port is free. You're like, okay, directly ship it to there. That's the whole end game of it. Like manufacture anywhere and ship it to anywhere. Different ports, different manufacturing departments. My brother works in a place where it's like almost like cement manufacturing factory. It's like they have hundreds and hundreds and hundreds and thousands of trucks. I'm not joking about it. Like, just if I ever drove there and I have a dash cam there, all you're gonna see is like a giant truck. So that's not good for anybody. That's not good. So aim would be basically, even those places here around, they will be connected by smaller links, and those links will dump their main cargo to this system, dedicated freight corridor. So it's a very long-term stable backbone. Of course, it's not flashy, it's not high-speed railway network, but it's like a necessary thing that we have to do. And if we do this properly, if things are done correctly, because be mindful, 2 tracks have already been built, already been tested out, and results are really promising. Results are like, dang, people really want summer service where it's like, dude, it's cheaper and quicker. I want that. Like there is a very serious demand for that. So it's a long-term investment in India itself, and it will also boost made in India, because we do have places where it's like, hey, cement is here, we have PCB manufacturers here, we have nut bolt manufacturers who are in Chennai. That's the whole reason why China is so efficient. It's like they have one place that makes everything. It's like, just get out of the door, that road is PCB, that road is nut bolts, that road is for metal case, that road is for this. So of course India is not that efficient, but if we can connect all these things, we will have our own advantages, and we have 3 ports. So there is a lot of hope, and this has the actual potential to boost Make in India. So this was my basically presentation on dedicated freight corridor. Hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.